Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. Here now, second semester with Chapter 4, we are going to get started into basically the trigonometry semester of the course. So that'll be a lot of, I think, probably new material here this semester. So maybe some review components here and there, some things you maybe remember from geometry, but I do think a lot of what you see this year is going to now be new material. So a lot of terminology is going to show up in this first part of 4.1, actually quite a bit of conversions and whatnot too. So to start out, an angle is in what is called standard position if its vertex is on the origin and the initial side is along the positive x-axis. So if you have an angle that would be in standard position, meaning one of the two rays of the angle is along the x-axis there, and then just somewhere else here. And so one of the things that you'll see, theta is probably the most common label. This is alpha, this is beta. We'll use these two some, but by far and away you're going to see theta used quite a bit. So a couple of real key points here. Positive angles are measured counterclockwise. Negative angles are measured clockwise. The one way that I know you've all seen angles measured is in degrees. So we start out here at 0 degrees. Now, of course, if you do go all the way around 360 degrees, and certainly you can keep going around the circle forever and ever. Well, 0 all the way around is 360, so halfway is 180. Well, if halfway is 180, this quarter mark is 90 degrees. And then from here, if this is 90, well, the midpoint there is 45. So from here now, filling in kind of everything else. Well, you can look and see this marking is more than halfway. Well, these two marks are actually 1/3 and 2/3 of the way to 90. So here we have 30 degrees and 60 degrees. 30 is 1/3 of 90, 60 is 2/3 of 90. Basically, when you see this is what's going to be called the unit circle. When you see this, every large gap is 30 degrees. Every one of these smaller incremental gaps is 15. So here we have 30, 120, here's a 15 degree gap, 135, 150. 30 degrees, 210, here's a 15, so 225, 240, down here at the bottom, the line got cut off, but that's 270. Again, we have another 30 degree gap, 300, 15 is 315, and 330. So again, I'm going around in a counterclockwise direction. Had I gone the other direction, right here, this would be from 0 down, well, I shouldn't say down, but 0 going clockwise to 330 would be negative 30 degrees. And again, that's something that we'll certainly talk more about this semester. When we talk about fractional parts of degrees, they are measured in minutes or seconds. I know on the old analog clocks, we treat 1 degree like it is an hour. Then we say, of course, a minute is 60 seconds. So 1 degree, if you take, there are 60 minutes and 60 seconds in a minute. 60 times 60. 1 degree is 3,600 seconds. So if we're going to convert 54 degrees now, This actually says 54 degrees and 45 seconds. So what we will do is the fractional part, 45 minutes, we take divided by 60, which you may not even need a calculator for, but it's 0.75. So this is 54.75 degrees. Now, the next one here, negative 128 degrees, 30 minutes, and 15 seconds. Well, for the 30 minutes out of 60, which obviously, yes, is a half, and then the 15 seconds, we use out at 3,600. I know that some of your geometry books may have used the degrees, minutes, and seconds marking. I know one of the geometry books I taught out of about 20 years ago did. I don't know whether or not the more current ones we're using have had this for you guys. So from here, what you're going to do is, obviously, you can take 30 divided by 60 plus 15 divided by 3,600 is 0.504. Now, all you do with these is whatever the degrees are, negative 128, you just put that decimal out at the end. You know, one of the things, don't like say, okay, I'm going to add it on to this, because if you have a negative and you add that on, it actually changes what you get. Now, to go in reverse, 15.126 degrees. Well, if we are going to convert from decimals back to degrees, minutes, and seconds, we're going to use the calculator. So what you do, enter in 15.126, and then, like it says right here, you press second, and then the angle function is above your apps button, and then you just go down to the DMS, degrees, minutes, seconds conversion. Hit enter, and you can see this is 15 degrees, 7 minutes, and 22.8 seconds. So this one gets really exact. It even has a decimal portion of a second. But that's one of the things that you'll see used a little bit throughout Chapter 4. All right, there is another way we can measure angles. That other measure is what is called a radian. There's actually more than just two, but the two that we are going to look at will be degrees and radians. Now, if you go around the circle one time, I know I'm kind of going into this next page here, which we'll actually use before we come back and fill in the other marking. Well, one revolution is 2 pi radians. Basically, which is 6.28 radians. So if we come back to this again, 0 is right there. If you go all the way around once, it's 2 pi radians. You don't actually have to specify radians. You know, right here, if there are no units specified, radians are always going to be implied. You know, that's one of the reasons why you may or may not have noticed I did fill in a degree marking with everything either on the first page or even this page when I was using degrees. All right, so from here, you know, again, one revolution is 2 pi radians, kind of like the way I did before. If a full revolution is 2 pi, well, that means half of a revolution is pi radians. You know, if you think about the circumference of a circle is 2 pi times the radius, that's where this 2 pi comes from. We're just going to say that the radius is 1, so 2 pi times 1 is 2 pi. So halfway around the circle is pi. Well, if you only went, if this is pi, this is half of pi, or we're going to even say it's pi over 2. Well, if 90 degrees is pi over 2, 45 degrees, half of a half is a fourth. Now, we're going to talk a little bit about a conversion factor to help us do this. Well, if 2 pi is 360 degrees, divide by 2, so pi radians equals 180 degrees. So what we can now do, if we want to actually fill in the rest of these, we'll talk about here in a moment. But if you have pi radians, it's equal to 180 degrees. Now, I know sometimes when I talk about this, thinking kind of like stoichiometry back in chemistry. If we're going to convert from degrees into radians, there are pi radians in 180 degrees. If nothing else, whatever you want to cancel, I've got degrees on the top here, degrees on the bottom will cancel. And so I have 135 pi over 180. Now, eventually we'll even talk about some easy ways to convert these. 0.75 is 3 pi over 4. Well, if you go back even to your degrees, 135 is right there. So here is my 3 pi over 4. Here's another easy way to fill in a lot of these. Every 45 degrees is a fourth of pi. So here's 1/4, 2/4, which reduces to a half, 3/4, 4/4, or pi. Down here is 5 pi over 4. So again, 1/4, 2/4, 3/4, 4 over 4, 5 over 4. Down here is 6 over 4, or 3 pi over 2. And so again, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, and 7/4. And then when you get all the way around, 8 over 4 is 2 pi. Now, a way to convert, to get the others we'll talk about here in just a second. But again, negative 270 degrees. Well, if I take pi radians times 180 degrees, that's negative 270 pi over 180. Negative 1.5, so that's 3 pi over 2. Now, to actually convert the rest of these, 30 degrees. If I take times pi over 180, well, I'm going to go ahead and cancel out a 0 right away from each. 3 pi over 18 is pi over 6. So, to fill in the entire circle in radians, if you know every 45 degrees is 1/4 and every 30 degrees is 1/6, you can do all of these without a lot of conversions. So here's 1 over 6, 2 over 6, or 1/3. 1 over 6, 2 over 6, 3 over 6, 4 over 6, which is 2/3. So there was 4 over 6, 5 over 6, 6 over 6, which is 1, 7 over 6, 8 over 6, which is 4 pi over 3, 9 over 6, 10 over 6, 5 pi over 3, and then the last 30 degree, 11 pi over 6, and then of course at 2 pi you're back at 12 over 6. So again, that's a way that you can fill in the radians. Every 30 degrees is 1/6, every 45 degrees is 1/4, and certainly as we go, you know, those will get much easier to do. Now, if we're going to convert back to degrees, well, to convert to radians, you use pi over 180. To convert to degrees, we use 180 degrees over pi. Again, real easy way to know. I have a pi now in the numerator to cancel it. Usually need it in the denominator. So this is negative 180 degrees over 2, which is negative 90 degrees. 9 pi over 2. 180 degrees over pi. Pi's cancel. Here I'm going to actually do this. 180 divided by 2 is 90. And then 9 times 90 is 810. You can certainly take 9 times 180 and then divide. I just happened to see something I could do fairly easily, and then I didn't even have to worry about my calculator. All right, 2 over 1. This is radians. Now, we probably should have said here it's 2 radians times 180 degrees over pi. Well, for this one, 2 times 180 is 360 degrees over pi. I'm going to go ahead and leave this as an exact answer. Pi doesn't reduce, so that is what we're working with there. All right, something else that you're going to see. Sometimes we talk about a portion of a circle. Convert 5/8 of a revolution, 2 degrees, and radians. Well, 1 revolution is either 360 degrees or 2 pi radians. I'll be honest, when I look at these two numbers, 2 pi is a lot easier to work with. So I'm going to say we're going to first convert to radians. So 5 times 2 pi, 10 pi over 8, which is 5 pi over 4. Now from here, I can convert my 5 pi over 4 radians, and there are 180 degrees in pi radians. Well, pi's cancel. From here, 5 times 180 divided by 4, 225 degrees. So, had you found this first and then converted, that works fine as well. I'll admit that as we go forward, you're probably going to actually eventually prefer radians because they're a lot smaller numbers. But that's another topic that shows up in 4.1. Coterminal angles have the same initial and terminal sides. You either add 360 degrees or 2 pi. Basically, what a coterminal angle means is that you have more than one angle in the same spot on the circle. So like right here, 20 degrees. Well, 20 degrees from 0 is basically right here. You know, we don't have to be exact. Now, in order to find 2 coterminal angles, I mean, there are an infinite number. I can either add 360, 380 degrees. What that means, if I go all the way around once, plus 20, 380 degrees is in the same spot on the circle as 20. The other option, certainly if I had taken 20 minus 360, well, for that, it is negative 340 degrees. So what that would mean is instead of, I always like to say, if I take the shortcut 20 degrees, if I went all the way around back this way, negative 340 degrees. Again, whether I go 20 degrees counterclockwise or negative 340 degrees clockwise, we are in the same spot. That's what coterminal angles represent. Meaning, because you can go around the circle an infinite number of times or in a different direction, you can have different angle measures that put you in the same spot. Now, let's say you have radians, pi over 3. Well, you either add or subtract 360, or we add or subtract 2 pi. So for this, I am going to need a common denominator. So this is pi over 3 plus 6 pi over 3. This one is pi over 3 minus 6 pi over 3. So 7 pi over 3, or 1 minus 6 is negative 5 pi. over 3. Pi over 3 is roughly there. So again, if I went pi over 3 plus another revolution, there I am. Or if I just went this way, negative 5 pi over 3 puts me in that same spot. All right, just about done here. I know this first set of notes actually has a lot of terms with it. Complementary angles. The sum of the angle measures is 90 degrees or pi over 2 radians. Supplementary angles. Sum of the angle measure is 180 degrees or pi radians. So find the complement and supplements if possible. Well, to find the complement, we take pi over 2, which is 90, minus pi over 5. To find the supplement, we take pi minus pi over 5. So, again, a lot of common denominators. That's going to be something that shows up a lot this semester. It's also one of the reasons why we spent, several sections at the very beginning of first semester going back over rational expressions. So 5 pi over 10 minus 2 pi over 10 is 3 pi over 10 for the complement. Now, for the supplement, these red pens are all dying at about the same time. So 5 pi over 5 minus pi over 5 is 4 pi over 5. All right, one other one. And then there's a reason why we're also including this one. So complement for 5 pi over 6. Well, if we take pi over 2 minus 5 pi over 6, again, we do need to get a common denominator. So 3 pi over 6 minus 5 pi over 6 is negative 2 pi over 6, negative pi over 3. Now, what that means, there is no complement. Well, hopefully that makes sense if we go back to our radian measure labels. 5 pi over 6 is above 90. So that's why it doesn't have a complement. It does have a supplement when we take pi minus 5 pi over 6. 6 pi over 6 minus 5 pi over 6 is pi over 6. So there is the first part of 4.1. Like I said, I know a lot of terms, but these are terms that you're going to see all year long. Degrees introduced a new unit of measure that we will also use all semester long in radians.